Hello students, in this video lecture we will discuss based on three-way classification in a Latin square design. Okay, so here what is meant by three-way classification? So we consider three different factors. One factor is column wise, another factor is row wise, another factor is we consider letters wise. For example, we consider column wise is a different variety of seats. Okay, we consider row wise is different types of plots. Okay, we consider letters is different types of name. Okay, that is called three-way classification. Let us see one example. Analyze the variance in the Latin square design of yield in kilogram of paddy, where PQRS denote the different methods of cultivation from the given data. Okay, here, what is our target? Examine whether the different method of cultivation have given significantly different yield or not. Okay, so in this problem clearly they mention Latin square method. Let us consider the given problem does not mention name Latin square method. So in that case we have to identify how to identify this problem belongs to three-way classification. Let us see what is they given the different methods of cultivations, how to do cultivations. So we consider three different factors. Okay, one factor we consider column wise. Okay, in column wise always we consider seeds, variety of seeds, otherwise variety of different treatments. Okay, treatment is nothing but sample size. Okay, so we consider column is what variety of seeds. Next to row wise we consider different types of land or different types of plot. Next, we consider what letters. Letters stands for different name of the seeds. Okay, here they given PQRS, four seeds. We consider four different name of the seed: P seed, Q, R, and S. So this is the way we have to identify three-way classifications. Okay, so solution. The given problem is three-way classification because one factor is column, second factor is row, and third factor is letter. Here column we consider different types of seeds, row we consider different types of plot, letters we consider name of the seeds. Okay, so here we shall use coding data. Okay, so students, suppose you don't know what is mean by coding data means, please refer my previous video lecture. In that video lecture, I have explained clearly what is mean by coding data. Okay, from the given data, we have three-digit numbers are there. If we take a square, we get six-digit number, and also we get values are big values. Okay, so that we are going to so that we try to convert three-digit into single-digit number. Okay, so that we shall subtract 120 from each values. Okay, so for example, what is 122 minus 120? We get what 122 minus 120 we get 2. Similarly 121 minus 120 1, 123 minus 123, 122 minus 122. Similarly we get these four values. Okay, once you get x1 x2 x3 x4 values, after that we are what add four values, we get what sum of x1 value. What is sum of x1 value? 8. Similarly, adding this 4 value, we get sum of x2 value, that is 6. Similarly, we get sum of x3, that is equal to 6, and a sum of x4 equal to what? We get 10. Once you complete a column wise, then similarly adding row wise. Okay, what is sum of y1? If we add this 4 value, we get sum of y1 equal to 8, sum of y2 equal to 14. Adding these four values, you get 0. This is called sum of y3. And finally, we get sum of y4 equal to 8. After that, adding these four values in column wise, we get 30. At the same time, we should get row wise also same value, we get 30. Okay, if we add this four value, you get 30, which means adding column wise or row wise, we should get the same. Okay, then only your data is correct, otherwise it is wrong. So we get 30. Okay, once you complete this portion, next taking square of x1 x2 x3 x4, no need to take row wise, we are taking only column wise. Okay, what is sum of x1 square? 2 square 4, 4 square 16, 0 square 0, 2 square now 4. Yeah, then that's all. Similarly, we get x2 square, x3 square, x4 values square. After that, adding these four value, we get sum of x1 square equal to 24 and sum of x2 square equal to 20 and this sum of x3 square equal to 14. Finally, we get sum of x4 square equal to 34. Okay. Once we complete a table values, now we go for a step by step. What is step number one? Step number one, we define a null hypothesis and the alternative hypothesis. So usually we consider null hypothesis is H naught and alternative hypothesis is what? H1. Okay. So here H naught is we consider there is no significant difference between columns, between the rows and between the letters. So here between the seeds, between the land, between the letters, that means seeds, name of the seeds, PQRS. Okay. H1 is nothing but negation of H naught. That means there is significant difference between the columns, rows, letters. Okay, this is called step number one. Step number two, we define level of significance. In this problem, they are not mentioned level of significance. So if suppose they are not mentioned, usually we consider 5%. Okay, so therefore the level of significance is 5%, which is nothing but 0.05. Next, we go for step number three. Step number three, to find variance ratio. If we want to find F, first we find what is N. N is nothing but number of observation. From the given problem, we have four rows and four columns. So if we count these four rows and four columns, we get 16. Listen very carefully. In three-way classification, that means Latin square method, always you should get what? Rows and columns are equal. Once rows and columns are equal, then only we can apply Latin square method. Otherwise, we are unable to proceed we are unable to solve this problem. Okay, but in two-way classification, rows and columns are equal or not equal, we can able to apply two-way classification. But three-way classification, rows and columns are, which should be equal. Okay, so here four rows and four columns are there. Next, we find a T. T is sum of all the observation. What is sum of all observation? We get 30. Next, we find N. Here, N is nothing but number of columns, otherwise number of rows, otherwise number of letters. Okay. From the given data, we have four columns are there. Row also four rows and also letters. Four letters are there. One is P, Q, R, S. So four different letters are there. So N value is 4. Next, we find the correction factor. What is correction factor formula? T square by N. 30 square by N value is 16. We get 56.25. Okay. Next, we find SST. What is SST? Sum of square of total value. That is nothing but sum of xi square minus correction factor. We have four square terms. Sum of x1 square, sum of x2 square, sum of x3 square, sum of x4 square, and also we know sum of x1 square 24 plus 20 plus 14 plus 34 minus correction factor value, we get 35.75. Similarly, we find the SSC, sum of square of column wise. So we know formula, each column what? Each columns are having same numbers. Okay, that's why we write 1 by n into sum of x1 square, sum of x2 square, sum of x3 square, plus sum of x4 square minus correction factor. What is sum of x1 square? 8 plus 6 plus 6 plus 10 by 4. We get 2.75. Next, we find SSR, sum of square of in row wise. So, same formula, we write y1 in terms of x1, we write y1, y2, y3, y4 minus correction factor. Here you see y1, sum of y1 8, 14, 0 square, 8 square by each row having sample size is what? 4. So 1 by 4. Using calculator, we get 24.75. Next, we find SSL. How to find SSL means, what is meant by L? L is nothing but what? Between the letters. So from the given data, we're going to arranging the letters wise in row wise. Okay. If you see given data, we get a p-value. Okay. For you see the given data in row wise. First we are arranging p-values. What is p-value in first row? 1. Second row 2. Third row 0. Fourth row 2. So we get what? 1, 2, 0, 2. So we get this value 1, 2, 0, 2. Similarly, we are arranging second letter Q in row wise. In first row, Q value is 2, second row 4, third row 0, -1, fourth row 1. After that, adding this 4 value, we get sum of P, which means we consider P notation is Z1, Z2, Z3, Z4. So we get sum of Z1 equal to 5, sum of Z2 equal to 6. Similarly, we get these two. So sum of Z3 equal to 9 and sum of Z4 equal to 10 by total number of sample size 4444 in letters wise. Okay. So we get a sum of square of in letter equal to 4.25. Okay. Next we find a SSE sum of square of error. How to find error? Subtracting from total value minus column wise, row wise, letters wise. So sum of square of between errors equal to 4. Okay, now we write ANOVA. There are 5 different categories. Some variation, source of variation, sum of square, degree of freedom, mean square, variance ratio. First, we write between columns. What is the difference between ANOVA 1, ANOVA 2, ANOVA 3? In ANOVA 1, we consider only between columns and the errors. Second one, between columns, rows, errors. ANOVA 3. Third one, columns, rows, letters, error. SSC 2.75, SSR 24.75, SSL 4.25, SSE error value 4. If we add this 4 value, we get 35.75. Already we found this value also. Next, degree of freedom, n minus 1. Number of columns, 4 columns, we get 3. Degree of freedom, row wise, how many rows? 4 rows. So 4 minus 1 equal to 3. Next, L, letters, how many letters? 4 letters. So we get 3. Within errors, what is formula degree of freedom? N minus 1 into n minus 2, we get 6. Next, adding these 4 values, we get n square minus 1. N value is 4. 4 square na 16. 16 minus 1 equal to 15. Next, we find the mean square between columns, rows, and the letters. So, what is MSC? MSC equal to SSC by n minus 1, which means divide this number by this number 0.92. Similarly, we get MSR 24.75 by 3, we get 8.25, and finally we get MSL, mean square of what? Letters. So SSL by n minus 1, we get 1.442. Next, we find MSE. MSE is nothing but SSC by n minus 1 into n minus 2, we get a 0.67. So in three-way classification, we find the variance ratio in 3 category. One is column wise, another one is row wise, another one is letters wise. So always numerator value is what? Comparing denominator, we should get numerator value is highest value. Why? Because in variance ratio what? In final answer, it should be greater than 1. We should not get less than 1. Okay. So therefore, variance ratio in column wise, that is 0.92 by 0.67. Highest number. So MSC by MSC, we get 1.37. After that, we find degree of freedom. What is degree of freedom in MSC? N minus 1, comma, this number. So 3, comma 6 by using statistical table value 4.76. Similarly, we find variance ratio in row wise. Row wise means this is 8.25. Error value 0.67. Obviously, numerator value is what? We should get big value. So MSR by M. So we get 8.25 by 0.67. We get 12.31. Next, we find degree of freedom for in row wise. What is degree of freedom in row wise? N minus 1. Error value n minus 1, n minus 2. So we get 3, comma 6. By using statistical table value, we get 4.76. Next, we find the variance ratio in letters wise. Letter value, what? 1.4 to 0.67. MSL by MSE, we get 2.12. And degree of freedom is what? N minus 1, comma this number, we get 3, comma 6. That means by using statistical table, we get 4.76. Next, we write step number 4. Step number 4 is critical value at 5% level of significance of the degree of freedom. Column wise, row wise, letters wise, we get 4.76. Next, we find step number 5. What is step number 5? we have to give three different conclusion. One is row wise, another one is column wise, another one is letters wise. Okay. So what is our conclusion? How to give conclusion? Obtained value is strictly less than a table value, then H naught is accepted, otherwise rejected. Okay. First we give conclusion for column wise. The computed value of in column equals 0.37 is strictly less than what table value of in column wise 4.76. So obviously this is biggest value, therefore it is strictly less than. Therefore what H naught is accepted. What is H naught? There is no significant difference between the columns. What is your column assumption? We consider variety of seats. Okay, next we give conclusion for a row wise. The computed value in row equal to 12.31, table value is 4.76 in row wise. Obviously we know, obviously we can say that what it is greater than, therefore H naught is rejected. What is rejected means what? H1 is accepted. What is H1 statement? There is significant difference between the rows. So here row is what we consider different types of plot or different types of land. The next one, we give third conclusion in letters wise. The computed of variance ratio in letter 2.12. It is strictly less than table value of in letters 4.76. Therefore, hence H naught is accepted. What is a H naught statement? There is no significant difference between the letters. So, what is your letters? P, Q, R, S. I hope you are enjoying this session. Thank you.